So using that power rule, find an equation for the tangent line to the function f of x equals x to the fourth that passes through 3, 81. So if we're going to pass through 3, 81, let's first get a sense of what's going on. If we draw just a real quick sketch of what's going on here. X to the fourth shoots up really, really quickly, right? We shoot up massively, very, very quickly with x to the fourth, right? By the time we've made it to a horizontal x location of 3, we are spitting out an output of 81, right? 3 to the fourth is 9 times 9, which is 81. So we're at this very, very high point very, very quickly. So what we're going to want to find is we want to find the tangent line to the function at this point, 3, 81. So we want to find something that winds up going like this, right? That's what we're looking for. What is the slope at this? Well, to find the slope at any given horizontal location, at any point, we wind up taking the derivative. So how can we take the derivative if we've got f of x equals x to the fourth, f of x equals x to the fourth? The power rule says that we can get the derivative, f prime of x, by taking the exponent and bringing it down in the front. So we've got 4 times x, and the exponent goes subtract by 1. So 4 minus 1 becomes 4 times x cubed. So if we want to find out what is the slope, so the slope at x equals 3, right? That's the horizontal location we're considering. Slope at x equals 3, if we want to find out what the slope is for our tangent line. The slope at x equals 3 is going to be f prime of 3. F prime of 3 will be 4 times 3 cubed, right? We plug it into our f prime, our derivative function. F prime of 3 equals 4 times 3 cubed. 4 times 3 cubed is 27. 4 times 27 equals 108. So we now know that the slope of our tangent line is 108. So if we're going to work out the tangent line, so our tangent line is going to wind up using this slope, m equals 108. So any line at all can be described by slope-intercept form. It's a really good form to have memorized, y equals mx plus b. You always want to keep that one in your back pocket, always useful. Y equals mx plus b. Well, we just figured out that the slope, if it's going to be the tangent, it must have a slope of 108 because f prime, the instantaneous slope at 3, f prime of 3, comes out to be 108. So we know the instantaneous slope at the point we're interested in, 3, 81, is 108. So that means we've got y equals 108x plus some b that we haven't figured out now. So how can we figure out what is b to finish creating our equation for the tangent line, right? If you're going to figure out what any line is, you need to know what the slope is and what the y-intercept is, what m is and what b is. So, at least if you're using slope-intercept. Y equals 108x plus b. Well, do we know any points on that line? Yeah, we're looking at the tangent line. And we were told that the tangent line passes through the point 3, 81. So we can plug in the point 3, 81. Because we know that our tangent line has to pass through the one point that it barely just feather touches on that curve. So we plug in 3, 81, so that's 81 for our y value equals 108 times 3 for our horizontal value x plus b. 81 equals 108 times 3, that comes out to be 324, plus b, 81 minus 324 is negative 243 for our b. So now we know negative 243 equals b. We know what our slope is, so that means we can describe the tangent line in general as y equals 108 times x minus 243. Y equals mx plus b with our m and b filled in. And now we have the tangent line that passes through the point 3, 81 and is tangent to the curve created by x to the fourth. Pretty cool. Calculus gives us a whole bunch of stuff that we can wind up doing with the derivative. The derivative is this massively useful, important thing. And we're just barely touching the surface of how incredibly useful and cool this thing is. As you work through calculus, you'll wind up learning a whole bunch of things that the derivative lets us do, lets us learn about a function. It's really amazing how much information it gives us. Calculus is really cool. I hope at some point you get the chance to take calculus and get to see how many cool things there are. And remember, when you work with the derivative, what you're looking at is what is the slope of that location, of that point or that horizontal location on your graph. All right, we'll see you at Educator.com later.